we've now seen a couple of examples of balancing chemical equations. And you've seen that, okay, if, let's say we're trying to balance this equation right over here, and we started with the carbons. I have two carbons on the reactant side. They're both sitting in this ethylene molecule. And so I would want two carbons on the product side. And right now I only have one carbon on the product side. And so what we've done is let's just put a 2 out front here. And so now we have 2 for every molecule of ethylene, and we're not done balancing this chemical equation yet. We're now producing 2 molecules of carbon dioxide. But one thing that you might have been thinking, well, why put this big 2 out front of the entire carbon dioxide? I like the way these little subscript little 2's look. So why not put a 2? Why not put a 2 right over there? And the reason why you can't do that is that's actually changing the molecule. It's no longer carbon dioxide. It's now this bizarre thing that doesn't really exist in nature, which is the C2O2 thing. You're actually changing the reaction when you're doing that. When you're balancing chemical reactions, the reaction itself is even before it's balanced, it's describing something that happens. It's just when it's unbalanced, it just doesn't have the numbers right. It doesn't have the numbers right in terms of number of molecules. So the only thing that you can change when you're changing these is the number of molecules. You can't change the number of constituents within a molecule, and that's why we do not change these subscripts. And if you want to visualize it a little bit differently, let's draw each of these molecules. So ethylene looks like this. So double bond with the carbons, and then each carbon is bonded to 2 hydrogens. Notice you have 2 carbons and 4 hydrogens. Molecular oxygen, O2, looks like this. It's oxygen double bonded to oxygen. And then you have carbon dioxide. Carbon dioxide is a carbon double bonded to 2 oxygens each. And then finally, you have water. Finally, water. Actually, let me do this in a different color. Your water right over here, this is an oxygen bonded to 2 hydrogens. So let me write the plus signs there. So plus this right over there. So if you were to somehow write a subscript of 2 right over there, you'd somehow be changing the structure. You would be changing what this molecule is. As opposed to that, which we don't want to do, we want to say, okay, we're definitely producing carbon dioxide. We're definitely producing carbon dioxide, but how many carbon dioxides do we produce for each molecule of ethylene? And so that's where we say, okay, we have 2 carbons here. We want 2 carbons here. We don't want to change the actual structure here. So let's write the 2 out front. So we're going to have 2 of these. Or if you want to do it, if you want to have it more visual, you could write, okay, we're just going to have another molecule here. We're just going to have another molecule. So now we've balanced the carbons. 2 carbons on the reactant side, 2 carbons on the product side. And then you go to the hydrogens. You say, okay, we have 4 hydrogens here. We only have 2 here. Well, what if we had 2 of these water molecules? So let's draw another water molecule here. So OH. And actually, let me write this right over here. So now we have 2 of these, and now we have 2 of these. And now we want to balance the oxygens. So we'll see, on this side we only have 2 oxygens. On this side we have 1, 2, 3, 4, 5, 6 oxygens. So in order to balance, in order to have 6 oxygens on the reactant side, we need 3 of these molecules. So another one and another one right over there. And now we're all balanced. We have 2 carbon atoms on both sides, carbons. We have 4 hydrogen atoms on both sides. Here they're in the ethylene, here they're in the waters. And then we have 6 oxygen atoms on both sides. And here, some of the oxygens are in the carbon dioxides, some of them are in the waters, and here they're all in the molecular oxygens. But notice, we didn't change the actual structure of the molecules. We just changed the number of molecules we have, and that's what these coefficients in front of these molecular formulas represent.